So good morning, everybody. Um, Before we start, let me introduce myself. So I'm Richard Matias from Terahertz and also one of the course creators in the Asia Open Run Academy. So our topic for today is Open Run use case and then massive MIMO optimization. Okay, so I prepared the topics. Ito yung mga topics natin. So we will review first para at least meron tayong konting recap on the review of what is Open Run, and then Open Run architecture, Open Run alliance use cases, and then we'll talk about what is MIMO para at least meron tayong idea what is a MIMO, what is beamforming and massive MIMO, and then we'll go through the Open Run use case, no? Yung ano yung application ng massive MIMO use case sa Open Run, massive MIMO optimization. And we'll end with the key learning points and some references. Okay? So let's start with the discussion of a typical run solution. So this is just a quick overview of the Open Run. Okay, so a typical run solution and an architecture, we have a core network of 5G or 4G. So we'll start with the 4G and 5G already, no? And then connected tayo sa ating cell site, which is yung ating radio access network via backhaul network. Okay, and then in our radio access network, we can see there physically nandun yung ating BBU or yung baseband unit and the RRU or the remote radio unit. So physically ganitong itsura ng site. Typical na makikita natin sa mga cell sites when you go out and then look around sa mga klase ng radio access network. So meron tayong tower structure and then you can see the remote radio unit. These are the RF circuitry of the base station enclosed on a small outdoor module. Yan, ganyan lang itsura niyan. And then, it may vary on different frequency bands. Like for example, meron tayong mga RRU na band 3, meaning 1800 MHz, and band 8, 900 MHz. So, it depends on the different frequency bands. And then itong mga remote radio units na to, nakakonekta ito sa ating mga antennas, which are directional antennas or panel antennas, which could be frequency specific din. So meron tayong mga low band antennas like the 900 MHz and the 1800 MHz. And connected yan sa ating RRU via jumper cables. And then meron tayong common public radio interface papunta sa ating baseband unit at sa ating outdoor cabinet which house the battery, power supply, and ventilation ng ating equipment. And then nandito rin yung ating backhaul network. So in this example, we use a microwave antenna as a backhaul network papunta ng core network. Okay, so ang topic natin mamaya is all about the antenna solutions like the massive MIMO and the MIMO technology and the beamforming. Sa pag-uusapan natin, what are the difference, no? Anong pagkakaiba ng mga yan? Yung MIMO, massive MIMO, and then beamforming technology. Okay? So let's start with the Open Run. So just a recap, Open Run means Open Radio Access Network. So this is an industry standard na nagde-develop ng disaggregated and interoperable radio access network solutions. So meaning disaggregated, hiwalay, no? Pinaghihiwalay natin yung mga functionality and hardware and software from the previous or legacy implementations. Like for example, in this scenario, previously sa 5G, meron tayong BBU. So what happens sa ating BBU, pinaghiwalay natin siya into two, the centralized unit and the distributed unit. Okay? So when we talk about Open Run, this equipment in the radio unit and the DU and the CU are now using general purpose processors. So you can buy it to the local OEM or international OEM, no, yung mga nagma-manufacture ng mga servers na yan. Aside from the major vendors na ginagamit natin ngayon, like for example si Huawei, si ZTE, si Nokia, si si Ericsson, no? Yan. Ito yung mga typical vendors natin. And then, it also has the software-defined technologies. Okay? And of course, yung mga interfaces natin dito is open. So meaning we can mix and match yung ating mga remote radio unit and also the software. Okay, so this Open Run evolves. Balikan lang natin yung evolution. So nagsimula tayo, nandito tayo ngayon sa traditional network, okay, where the baseband and the radio unit are located in the cell site premises. And then later on, nag-evolve yan into centralized network in which yung ating mga baseband na dating nasa cell site natin are located no sa ating mga central office, no, para for pooling of resources. And then later on, yung ating mga baseband ay virtualized, no. So meaning yung functionality ng baseband are virtualized, and then we are now using COTS, no, or commercial off-the-shelf servers, no. Hindi na yung mga proprietary baseband natin na ginagamit previously. Okay, so gumagamit tayo ng COTS hardware, pero ang naging limitation lang nitong virtualized run is still the interfaces, still proprietary. Okay, so hindi pa rin siya open. And then later on, nandito tayo sa Open Run. So Open Run, gumagamit na siya, no, ng disaggregation. So pinaghihiwalay natin yung functionality ng BBU. And then gumamit tayo ng mga cloud native functions, network functions. And then yung mga hardware natin is general purpose processors. And then yung ating interface is now open. Okay, so you can now mix and match different vendors with softwares dito sa ating system. Okay? So this is the evolution of the radio access network. And then there is an organization that helps, no, in producing the specifications for the Open Run. So this is a group of telecom companies that aim to improve the performance ng openness of their network. So ito si ORAN Alliance. Okay? So si ORAN Alliance was formed way back 2018 of February, na meron silang goal of promoting open and intelligent. So those are the two keywords, open and intelligent RAN. Okay? So it was created by merging two organizations. So una is yung the CRAN Alliance. Si CRAN Alliance is composed of China Mobile and other mainly Chinese vendors, plus si XRAN. So si XRAN is composed naman ni NTT Docomo and other mainly American vendors. So nung nag-combine sila, tinawag silang ORAN Alliance. Okay? And the founding operators ng ORAN Alliance is the AT&T, China Mobile, Deutsche Telekom, NTT Docomo, and Orange. Okay, so this is the ORAN Alliance. So si ORAN Alliance, okay, is a group of telecom companies nga, no? So ang pinaka objective nila is to have an open and intelligent system, no? So, meron silang pinropose or meron silang dinevelop na architecture, which is the ORAN architecture. So, ibabalikan lang ulit natin yung ORAN architecture natin because mamaya pagdating ng Massive MIMO or nung Massive MIMO optimization, pag-uusapan natin yung architecture na to. Okay? So, the ORAN architecture, ito yung ating ORAN architecture. So, meron tayong Service Management Orchestration or yung SMO. Okay? So, si SMO, nandyan si non-real-time RIC. Ibig sabihin na non-real-time is run intelligent controller, yung RIC. So, dito sa non-real-time RIC, it supports intelligent run optimization in non-real-time. Ibig sabihin, ito yung mga activities or mechanisms that operating greater than 1 second. Okay? So, dito nangyayari yung mga policy-based guidance. So, ano yung gusto nating i-implement sa network? So, when we say policy-based guidelines, gumagamit ito ng data analytics. Okay? And artificial intelligence, machine learning, training, and inference. Okay, so ginagamit niya yung kanyang mga data. So mostly maraming data to, no? Big data ang ginagamit natin for analyzing and using the algorithm ng artificial intelligence and machine learning. Ibababa niya yan kay near real-time RIC or NRIC, no? NRT, Run Intelligent Controller. Okay? So si NR or si near real-time RIC naman, ang ine-enable naman nito is mga real-time control and optimization. Okay? So it has a direct control sa ating OCU, centralized unit, at distributed unit. So anything na mga activities or services within or less than 1 second or from 10 milliseconds to 1 second ay hinahandle ni near real-time RIC. Kasama dito yung monitoring, suspension and stopping, override and control of the primitives behavior of the ORAN nodes. Okay? Yung mga parameter changing ng mga ORAN nodes ito inaano ni near real-time RIC. Nagaling kay non-real-time RIC na mga policy guidelines. Okay? So, si near real-time RIC, meron siya mga tinatawag na XApp. Ito. Na connected via E2 interface to collect yung mga near real-time run information, okay, to provide value-added services using these primitives. So, guided yan, no, ng policies and rich data provided by the A1 interface na galing dito kay non-real-time RIC pababa sa kanya. Okay? Si centralized unit naman, okay, so it runs the radio resource control or RRC and the packet data convergence protocol layer. Okay, so ibig sabihin yan, so yung mga functions like yung transfer of user data and mobility control, run sharing position, session management, dito yan, nandito kay centralized unit. And si distributed unit naman, siya ang nag-handle ng radio link control, MAC, and high physical functions, including yung mga layer 2, scheduling, and physical coding and scrambling. Okay. And then si ORU or remote unit includes yung radio frequency front end, okay, and digital front end to transmit and receive yung mga over-the-air signal. And then dito rin nangyayari yung beamforming and other physical layer functions. Okay. So RU, gumagamit ito ng integrated hardware, software, and basically hindi ito disaggregated, no? In the classic sense of open interfaces to connect to the DU. And then meron tayong OCloud. So si OCloud is the cloud computing platform comprising yung mga collection of physical infrastructure, okay, nodes that can host the relevant ORAN functions. Kasama dito yung mga supporting software components and yung mga appropriate management and orchestration functions. Okay? So makikita natin dito sa ORAN architecture, it is based on disaggregated components, no? And mga interfaces which include yung mga enhanced 3GPP interfaces. Kasama dyan sila F1, okay, yung connection ni CU at DU. E1, connection ng OCU CP, control plane at user plane. X2, no, kung connected tayo sa kabilang LTE. Or XN sa kabilang G-Node B. So, yung mga basic or fundamental interfaces na ginagamit sa 3GPP, ginagamit natin sa ORAN. Okay, so dahil naka-base tayo sa 3GPP standard. And then, meron din tayo mga additional ORAN Alliance specified interfaces. Kasama dyan yung mga open front hole interface. Okay, ito. Sa DU and ORU. So, ito is ORAN ORAN interface. Andyan din sila E2. Okay, dahil bago ang near real-time RIC or yung mga RIC, yung Run Intelligent Controller, so si ORAN Alliance ang nagano niyan, no? Nag-specify ng interface na yan. E2. And of course, yung A1. Yan, so si Service Management Orchestration papunta kay near real-time RIC. Okay, so ito yung ating ORAN architecture. So later on, mamaya pag-uusapan natin yan. And then pupunta tayo ngayon sa ORAN na use case, ORAN architecture. Ano bang mga benefits ng ORAN architecture? Why do we need to implement yung ORAN architecture? So the benefits of ORAN architecture, number one, ORAN is capable of reducing network capex and OPEX. Okay. So yung mga interfaces niyan, ini-eliminate natin yung mga single factory. Okay, kasi dati kapag order tayo ng mga equipment, so ano yan, minamanufacture yan. Hindi yan readily available. So kapag ang ating system is open and then everybody can participate, so we could facilitate yung multi-vendor cooperative deployments. Okay, so ini-enable natin yung mas maraming competitive and vibrant supplier system. Okay? And si ORAN is also capable of improving network efficiency and performance. So paano niya ginagawa yan? So yung dalawang dalawang keywords natin sa ORAN architecture is openness, okay? And intelligence in run. So yung intelligence in run, kapag meron tayo nito, it reduces OPEX. OPEX means operational expenses. So kapag for example, ang example ng OPEX is pag bumili ka ng sasakyan. So pag bumili ka ng sasakyan, ang pinambayad mo ron is yung CAPEX, capital expenditure. While OPEX is mostly on the operating expenses. Like for example, yung gasolina mo, okay? Yung bayad mo sa driver, kung meron kang driver, ayan. And yung maintenance ng vehicle mo is part of the OPEX. So sa radio access network, marami tayong OPEX, Like for example, yung optimization is considered as OPEX. Lalo na yung mga manual changing of parameters. So kapag yung ating radio access network is intelligent, meaning it can do automation, okay? And then there is an embedded intelligence in every layer ng RAN architecture, and then leverages yung mga new learning based sa technologies, and then kaya nating i-automate yung mga operational network functions. It reduces operational activities. Kapag nabawasan yung yung operational activities, definitely it will go to lower OPEX. Okay. And third is ORAN is capable of importing new capability with great agility. Okay. So ORAN makes it easy to import yung mga new network capability dahil sa mas madali tayo makapaggawa ng software upgrade and with its native cloud infrastructure. So ito yung mga benefits ng ORAN architecture. Now si ORAN Alliance ay meron din siyang mga use cases na pinopropose. So yung kanyang mga use cases is divided into two phases. Okay? So meron tayong phase 1. So yung phase 1, ito yung mga use cases na binanggit ni ORAN Alliance. So when you say ORAN use case, ito yung mga use case that both leverages yung ORAN architecture and demonstrates yung unique benefits. Okay, so yung mga key benefits of ORAN architecture, kasama dyan yung utilization of machine learning systems and artificial intelligence, and then empower yung network intelligence through open and standardized interface in a multi-vendor network. Okay, so nandito yung, for example, sa phase 1, yung low cost RAN white box hardware. Okay, so pag sinabi nating white box, it refers to yung mga packaging that only contains the hardware with limited or no software or documentation. Okay, so yung mga white box product is commonly cheaper than the standard product na purchased from a retailer or yung from typical vendor. Okay. And then next is the traffic steering. Okay, so traffic steering is an evolution. Okay, evolution yan ng mobile load balancing. Sir, ano po yung mobile load balancing? So like for example, no, meron kang dalawang band ng LTE. Meron kang LTE 1800 and then meron kang LTE 2100. So yung load balancing, meaning binibigyan niya ng optimization engineer ng parameter. Okay? May parameter. So like for example, malapit ako sa site, maganda yung aking quality dito sa L2100, pupunta ako sa L2100. So yung L2100 ang gagamitin ko. But there will come a point na dadami yung subscriber sa loob ng L2100. For example, ang sinet na parameter lang ng optimization is around 50 users sa L2100. Pagdating natin sa 51st, no? 51st ba? 51st user. Okay? Ang mangyari dyan, hindi siya tatanggapin sa L21. Papupuntahin siya ng system sa L18. So to enforce yung policy ng load balancing. Okay, so bakit tayo nag-load balancing? Siyempre para ma-maintain natin yung ating network quality and then yung user experience, no? Yung magandang user experience. Kasi kapag dumami masyado yung ating users sa isang L20 sa isang band, so magsisiksikan sila doon. So eventually magko-congest yan. So ito yung pinaka objective ng load balancing. Sa Open Run, meron tayo traffic steering. So evolution yan ng mobile load balancing. But now, this is now controlled by, nakikita natin, non-real-time rig and near real-time rig. So powered by artificial intelligence and machine learning. So hindi na tayo manually nag-a-adjust ng mga parameters dito. So kumukuha ang non-real-time rig dun sa SMO ng mga data or mga analytics, and then through the machine learning algorithm, gagawa siya ng policy. Okay, so kapag ganitong oras, marami pala yung user ko sa L2100. So mangyari natin, bababa niya yan kay near real-time rig. Na near real-time rig, ganito yung parameter na gamitin mo sa ganitong klaseng oras. Okay, so sabihan mo sila centralized unit na baguhin yung parameter para pumunta ang kalahati ng mga users natin papuntang L18. So, ganun yung ginagawa nila. So, hindi na siya manual na ginagawa. So, it's powered by artificial intelligence and machine learning. And meron tayong mga QoE optimization. And then yan, ito yung pag-usapan natin mamaya, massive MIMO optimization and QoS-based resource optimization. Hindi natin isa-isahin, ano? Medyo marami tong mga use cases na to. Ito yung phase 1. And then phase 2 is the run sharing na pinag-usapan natin last 2 weeks ago. Okay, run sharing. And then meron tayong run slice, service level assurance. Meron din tayong context-based dynamic handover management, no? Yung for V2X, yung vehicle to everything. Yan. And then flight path-based dynamic. So, unmanned aerial vehicle, resource allocation, and yung mga radio resource allocation for unmanned aerial vehicle applications. Okay, so ito yung mga use cases. So, today, yung pag-uusapan natin is more on the massive MIMO optimization. Okay? So, bago tayo magsimula dun sa massive MIMO optimization, let's briefly discuss ano ba yung MIMO. Okay? Bago tayo pumunta ng massive MIMO, and then meron tayong beamforming, mamaya maririnig niyo siya, no? So, ano bang ibig sabihin ng MIMO, sir? Okay, so when we talk about MIMO, Yan, when we talk about MIMO, MIMO means, or minsan sa iba maririnig MIMO. Okay, so it's either MIMO or MIMO. Ibig sabihin is multiple input and then multiple output. Okay, MIMO, multiple input, multiple output. So meaning, meron kang multiple inputs or different stream, no? More than one, no, na stream or source, and then meron kang more than one na receiver, yan, output natin after ng channel. So this is an antenna technology for wireless communications in which yung multiple antennas are used at both the source or the transmitter and the destination. So paano to gumagana, no? So ibig sabihin dati meron tayong isang antenna, nagka-transmit tayo ng isa lang, no? Isang stream lang. So basically kapag nag-transmit tayo for example ng ABC, no? So, tinatransmit lang natin A, B, C. No? A, okay, B, and then C. And then we transmit it one at a time, A, B, C. Okay. So, to increase the throughput or yung data transmission, gumamit tayo ng iba pang klase ng mechanisms ng antenna systems. Meron kayong maririnig na antenna diversity. So, antenna diversity naman is to overcome yung fading para ma-receive natin yung ating signal dahil yung ating RF environment is hindi naman siya ideal. So, maaaring magkaroon ng error during the transmission. So, yung receiver diversity is just like transmitting, no? Transmitting one signal, okay? But receiving twice, no? Pwedeng ganyan. Yan. So, kapag dalawa yung na-receive natin, we can do the signal processing dito na makita natin, ito pala, no? Kunyari, itong transmit ito is A, B, and then yan lang. Tapos ito naman, transmit is B and C. Ang na-receive niya lang. So, through the advanced digital signal processing, alam nung receiver natin na ang tinransmit niya is A, B, and C. Okay? So, ito yung gamit ng diversity. Okay? So, when we use naman yung yung MIMO, okay, so what is happening is that we are not transmitting one information only on each antenna. What we are transmitting is different signals or information at a different antenna. Like for example, mayroon ako ditong A, B, C, and then D, E, F. Okay? So this is transmitted here. Okay, and then this is transmitted here. Okay, and then this one is transmitted here. And this one is transmitted here. Okay? So, ang lumalabas dito is we are increasing yung ating data transmission. Okay? Because dalawa yung stream na pinapadala natin. And then different information agad. So, basically, sa isang transmission natin, may marireceive agad natin yung A, B, C, D, E, F in one time. Okay? So, ganun ka-significant ang MIMO technology. Pagdating sa cellular, hindi lang sa cellular, maririnig rin ng MIMO pagdating sa Wi-Fi. Ginagamit din natin yan. Okay, so this is the principle ng MIMO. And then before we go sa concept ng tinatawag nating massive MIMO or beamforming, puntahan muna natin yung basics, no, ng antenna. Balikan lang natin yung basics ng antenna para maintindihan natin. So, sa antenna, normally, meron tayong radiating element, okay? Meron tayong input signal, okay? And then, we have a radiating element. Ang nangyari dyan, para kang meron bumbilya, no? Ilaw. And then, what is happening, you will radiate the electromagnetic energy into space. Yan, or electromagnetic wave. So, habang dinadagdagan natin yung ating radiating element, no? Yung radiating elements natin, mas nagiging ano yung ating beam, no? Mas nagiging narrower yung beam natin. Okay? And then kapag nagdagdag pa tayo ng 4, no, na radiating elements, mas nagiging narrower yung beam natin. And then mas tumataas yung gain natin. Okay? So ganito yung nangyayari sa antenna natin. Pero paano nangyayari yun, sir, no? Paano nangyayari yan na nagdadagdag lang tayo ng radiating element, nagiging narrow na yung beam natin. No? Mas nagkakaroon tayo ng control, ibig sabihin. Just imagine, no? When we are initially transmitting in this scenario, and then the users are just located at the main lobe ng ating antenna, marami tayong nasasayang na energy. Ito, sayang tong energy na to, no? So, para tayong nagtatapon ng power or energy sa space na hindi naman nagagamit. So, we want to become more efficient pagdating sa transmission. Okay? So, using a beamforming technology solves that problem. Okay? So, ayaw natin ng nasasayang na energy. Ayaw din natin ng wala tayong control in terms of the RF energy. Gusto natin, kung saan natin gusto i-steer yung beam, no? Gusto natin, doon natin sa i-steer. Ayaw natin siyang nakakalat, and then ayaw rin natin siyang nasasayang. Okay, so we are using this kind of technology. So for you to better understand paano nangyayari yung ano no, yung beam steering na yan no, or yung beam forming na yan. Later on, let me share with you some software no. So pwede kayong maglaro dito. Share ko sa inyo 'tong link no. Share ko yung link para lang mas maintindihan natin no, yung beam forming mechanism. I want you to understand the beam forming mechanism. Kasi most of the lectures ng massive MIMO and beamforming, mostly na napaka-technical, no? High technical. Pero in this session, I don't want to go onto the details and the mathematical explanation ng beamforming. Nasaan na ba yung chat natin? Okay, wait. Saan yung chat natin? Okay, I'll share it in the chat, no? Ito yung ating link. So, if you have a laptop and then you have some extra bandwidth, pwede kayong pumunta dyan. At basically, ito yung ating example ng simulation where you can also do the exercise. Okay? So, what I will going to do here is, gagawin natin is magpapabuga muna ako ng isang ano no, ng isang tubig. Yan. So, what we going to do para ma-visualize natin na yung ating tayo maganda ito. Ayan, para ma-visualize natin na yung ating wave. Yan. So definitely, yung nakita nyong droplet or droplets of water is coming from one radiating antenna. Okay? Coming from one radiating antenna. Okay, so ang nangyari, nagkakaroon tayo ng electromagnetic disturbance, no? Ayan. So, nagki-create tayo ng disturbance. So, we are changing, like for example, we are changing the charge, no? And then, sabi ni James Clerk Maxwell, so kapag ka merong change or varying charges, it is co-producing magnetic, no? Magnetic flux. So, kapag ka meron man tayong magnetic field, nagki-create naman siya ng electric field. Kaya meron tayong ano no, meron tayong tinatawag na electromagnetic energy. It co-creates each other. So dito ang nangyari is we are simulating a disturbance sa tubig para mas madali natin ma-visualize. Okay? So nagke-create tayo ng disturbance. So nakikita niyo yung wave, no? Electromagnetic wave. So it connotes no, it connotes the same procedure sa electromagnetic energy. So, ang gagawin natin, tataasan ko yung frequency niyan. So, ibig sabihin, pag tinaasan ko lang yung frequency niyan, nakikita nyo na, bumibilis naman yung cycle ng ating wave. Okay? And then, eventually, nakikita niya na mas maraming ripples ang napoproduce. Okay? Mas maraming ripples ang napoproduce. Okay? Pag binabaan naman natin yung amplitude, okay, babaan natin. So, humihina din yung power natin. Okay? Ayan, humihina din yung power natin. So, dalawang case ang gusto kong ipa-realize nyo dito. When we are varying frequency, and then we are varying amplitude, so there is a corresponding change sa ating output. Okay? Binabago natin yung amplitude, yung lakas ng pagpatak ng tubig. And then, somewhat, when we are changing frequency, like for example, we are changing the phase, actually, no? Phase. Kung kailan mag-start yung ating wave. So, ngayon, ang gagawin natin is we will simulate now itong ginawa natin. Ito yung una natin ginawa, no? Radiating antenna. No? So, nakita natin, nag-radiate yung ating electromagnetic energy. So, what we're going to do in our simulation, we will be using two radiating element. So, sasabihin natin, sir, paano naman nangyayari yan na ganyan, ano? Na nagiging narrow yung beam. Okay, so bago natin pag-usapan yan, pupunta muna tayo sa superposition theorem. So, the superposition theorem says that kapag ka mayroon dalawang wave, no, na nagbanggaan, no? Nagbanggaan sila, no? Dalawang wave na nagbanggaan na maparehas ng frequency at phase. Ang nangyayari sa kanila, nag-add up yung kanyang amplitude. Nag-add up. Tumataas siya. Tumataas yung kanyang power. And then, kapag meron naman tayong wave, no? Like for example, meron tayong wave na ganyan. Tapos, nag-add siya sa isang wave na merong Ayan, negative naman yung kanyang ano, na phase. Ang tendency is nagiging flat, no? Na naka-cancel out. No? Ito yung tinatawag nating um, destructive and constructive interference. Okay, so ang interference hindi lang lagi siya masama, no? Hindi siya lagi detrimental sa system. Actually, it's useful sa technology ng beamforming at massive MIMO. Okay. So pumunta tayo dito. So naintindihan na natin yung superposition theorem. So pupunta tayo ngayon sa ating exercise, no? Yung simulation natin. Balikan natin. So ang gagawin natin, patayin muna natin 'to. Patayin muna natin yung ating gripo at sasayang yung tubig. Mahal yung tubig. So ang gagawin natin, separate natin, no? Separate natin yung antenna element. Yan. Okay? So we separate the antenna element in such a way it is half of the wavelength. Yan, half of the wavelength. And then, bubuksan ko yung aking isang gripo. Okay? So nakita nyo, as is, meron tayong wave na napoproduce. Correct? So you can also try this, no? And then, later on, mag-activate ko yung aking next radiating element. But this time, the radiating element will be delayed, no? For some time. Okay? Yan. So, meron siyang konting delay. And then you can see the effect dun sa ating beam. No? So, what happened? Anong nakita nyo? Can you type in? Anong na-realize nyo dito sa ating experiment? When two radiating elements, no, are transmitting, for example, at the same time. So, meron tayo nung tinatawag na superposition theorem. Okay, superposition theorem. So, kapag ka nagbabanggaan yung dalawang wave, nagkakaroon ng reinforcement. Like, for example, here. Okay? Meron tayong reinforcement na nangyayari dyan. So, constructive interference ang nangyayari dito sa position na to. Okay? Sir, paano natin nasabi na constructive interference yan? So, tingnan natin. Gamitan natin ito. So, pumunta tayo dito. Okay? So, makikita natin na mataas, no, yung ating amplitude. Okay? So, it's an addition or the sum of the amplitude of these two waves. However, pumunta tayo dito sa lugar na to. Dito sa position na to. So, you can see what's happening. Ano nangyayari dyan? Sa position na yan? It almost cancels out, no? Nagka-cancel out yung ating signal. Kaya pagdating natin dito sa area na to, wala na tayong signal, no? Na naka-cancel out yung ating energy dyan. So, this now uses the concept ng beamforming natin. Okay? Okay, babalik ko lang to dito. Okay? So, nakita nyo, no? So, wala tayong signal dito sa kabila. We don't have any signal dito. So, kapag ikaw ay nandito sa lugar na to, wala kang signal dito. Pero, dito, sa area na to, kakaroon tayong signal. Okay? Meron tayong signal dyan. Okay? Yan. So, sir, paano naman natin siya babaguhin, no? So, meaning, the more radiating element you have, the more control ka dun sa iyong beam. Okay? So, pwede mong ma-steer yung beam mo. Like, for example, gawa natin ng konting experiment. Baguhin natin yung antenna separation. Okay? Babaguhin natin yung antenna separation. And then, let's try. So, makikita mo, iba naman yung beam na napoproduce niya. Ano nangyari naman dito? Ang beam na naproduce natin is more on nandito sa gitna. And then, medyo nawawala yung nandito natin. Ano? Okay? Medyo nawawala. So, tingnan natin, no? Baguhin natin. So, kunyari, meron tayong digital beamforming. Kunyari, ito ay naka-digital signal processing na. No? So, ang gawin lang natin is ganyan natin. Okay? So, nakita nyo, nagbabago ng konti yung aking power, yung aking direction ng beam. Okay? And then, hihinaan natin yung ating amplitude. Okay? So, kasi dito sa example to, hindi siya separately, no, nahihinaan, ano. Pero sa antenna, pwede nating i-vary yung amplitude and i-vary yung phase para ma-steer natin yung ating beam. Okay? Nagets ba kung paano gumagana tong ating beamforming? Yung ating basic ng antenna, yung antenna elements, ano yung effect ng number of antenna elements dun sa ating antenna. Okay? Can you show a thumbs up? Okay. Okay, so magandang simulation. So you can do the experiment para at least in terms of the theory and concept ng electromagnetic energy propagation, you will not be confused. Okay. Okay, so let's continue dun sa ating discussion. So nakita natin na habang dumadami yung antenna radiating elements natin, mas nagiging narrower yung ating beam. Nakita natin yan dun sa ating simulator using the droplet of water. So, ganun din ang nangyayari kapag binago natin yung ating, pag ini-steer natin, kahit na meron tayong 4 droplets of water, okay? So, once we change the amplitude and the phase nung ating signal or input signal, so we have the ability to steer the beam. Pwede natin siyang palikuin yung beam. Hindi lang siya nagtatransmit sa isang direction. Okay? So, ganun din kapag pinaghiwalay naman natin yung ating mga input signal. If we have 2 input signal 1 and input signal 2. And then you apply the concept of the beamforming here. Okay? Apply mo yung concept dito. So, you have a separate beam pointing in this direction. And then you have a separate beam pointing in this direction. So, what happens here? So, mas naging efficient yung ating pag-radiate ng electromagnetic energy. Previously, nagka-transmit tayo buo. Okay. So, right now, there are some areas na hindi natin kailangan ng energy. But now, we are focusing our energy into this direction. Okay? Ayan. So, ganito yung basics ng antenna natin. So, ganun din naman kapag marami tayong beam. So, meron tayong tinatawag na spatial division multiple access. Meaning, our users are located separately in geographical location or in space. So, magkahiwalay talaga sila. So, ang tawag natin yung spatial division multiple access. So, we can steer the beam from to left. So, kapag finocus natin yung energy natin sa isang beam lang, so we expect na mas malayo yung beam natin, mas mataas ang gain ng ating beam kung isang beam lang. Kung gagamit naman tayo ng dalawang beams, okay, so the energy will be divided into 2. Okay, so one beam pointing into this direction and into this direction, but lesser amplitude compared to this beam. And then if we use 4 beams, so ganito yung mangyayari. Okay, so less yung ating power. But we have 4 beams. So those are the trade-offs na pwede nating i-consider pag gumagamit tayo ng beamforming mechanism or beamforming technology. Okay? So yung beamforming, ito yung ating summary ng beamforming. So ito yung electromagnetic energy. So kapag tinignan natin yung ating system, we only have this phase shifter.
Hindi na ako mainit. Hindi nga.
Yeah. Okay. So meron tayong phase shifters. Okay? So yung phase shifters, ito yung pagdi-delay natin ng droplets of water kanina. Okay? Ito yung ginagawa ng phase shifters. Okay? And then we can also change the amplitude. Yan. Okay? So ito yung hybrid beamforming if we are using phase array of multiple beams. Yan. So anong mga benefits ng beamforming? It improves the uplink and the downlink. And then the uplink and downlink link budget and increasing the antenna gain. And then it helps to reduce intercell interference by focusing yung transmission natin, specific direction. Kasi dati, meron tayong isang beam na hindi natin makontrol, and then meron tayong isang beam na naman na hindi makontrol. So, in this area, this is an interference, So, interference zone. Kasi parehas tayo ng frequency. Okay? So, meron tayong interference zone. Kapag ang ating beam is focused, okay, although hindi to syempre hindi to ideal, pero at mas possible na lilimit natin yung ating interference zone. Okay, yung overlapping zone natin. Okay? Kaya meron tayong reduction ng inter-cell interference. And then, it provides support for multi-user, multi-user MIMO or MU-MIMO, and multiple users can be simultaneously allocated the same resource blocks. Mamaya pag-usapan natin yan. Paano ginagawa yan, sir? Okay? So, the more the antenna elements, the more the directivity. Okay? So, pagka tinignan natin sa simulation, ganito nangyayari. If we use a single antenna element, so ganito ang nangyayari. So, if you have a user here, so you can see the signal level, no? Or yung path loss malaki. So, ang daming nasasayang na energy into throwing into different directions. So, what will happen if we add more antennas, okay, we can focus our energy into that user. Okay, so remember yung pag-drop ng tubig, no? Droplets of water. Okay, the more antenna elements, the more steering capability that we have. And the more directivity our beam could be. So, kapag dinamihan natin yung ating antenna elements, okay, so yung ating beam is nagiging mas focus at mas narrower. So, tendency, mas lumalakas yung signal level niya rito. Okay, kasi yung energy natin already focused on a single beam. It's not anymore dissipated into different directions. Okay? Okay, so ginagamit din natin yung yung ating beam na yan, no, sa iba't ibang application as I mentioned. So, I'm not sure if we still have time, but maybe sa ibang session natin papakita yung isang video about beamforming sa mga satellite communications like yung Starlink. But later on we will move on sa sa area throughput definition. Okay. In area throughput definition, it is measured in bits per second per square kilometer. Okay. So we have a formula, like for example, the volume is the area throughput. So papaano tumataas yung throughput natin? Ano ba yung mga factors na nakaka-affect na nagpapabilis ng ating internet connection? Unang-una is the average cell density. So mas maraming cells, mas maganda. Kaya ini-encourage na magtayo tayo ng maraming cell site for capacity and throughput improvement. The bigger the bandwidth, the better. Okay, like for example, the LTE has a bigger bandwidth compared to UMTS. And then 5G has a bigger bandwidth compared to LTE. Kaya mas malaki yung ating throughput, no? Mas mataas ang throughput natin. And of course, spectral efficiency. So spectral efficiency is the use nung ating spectrum. How many bits per second per hertz ang pwede nating i-transmit? So napapataas natin ang spectral efficiency using modulation techniques. Like for example, QPSK, nakakapag-transmit tayo ng 2 bits, no, per hertz. And then for example, 16 QAM, we can transmit 4 bits. And then if we use 64 QAM, we can transmit 6 bits. So just like that's what spectral efficiency is doing. Okay? So ang formula lang yan is area throughput. So multiply lang natin yan. Ito, multiplied here, and this one. And then after that, so the bandwidth, average cell density, and then spectral efficiency. Okay? So if you're familiar with Shannon's formula, it also uses this Shannon formula, no? So meaning, yung ating data rate, okay, or capacity is equal to the summation of cells, no? Kung gaano karami yung cells natin in that area, and then multiplied by the bandwidth, and then with a good signal to noise ratio. Kapag maganda yung ating signal to noise ratio, our spectral efficiency will become high. So mas marami tayong bits of information na pwedeng ipadala. Okay, so paano natin siya nagagamit? So if we are fixed on a certain bandwidth, and then okay na yung ating signal to noise ratio, what we could do in this equation is to add the number of cells. Okay, so in the case of massive MIMO, mas marami tayong number of beams, and then mas marami tayong number of layers na pwedeng ipadala. Okay, so let's move on sa MIMO, no? So kanina pinag-usapan natin yung MIMO. Ano yung different types of MIMO? So we have different types of MIMO. So kanina, ang ibig sabihin ng MIMO is multiple input, multiple output. And then meron itong mga variants, like for example, SIMO, single input, multiple output. So you have only one transmit antenna and then you have 4 receive sa iyong sa iyong receiver. So it goes like a receiver diversity, no? Para siyang receiver diversity. And then you have this MISO, multiple input, single output. So you have 4 or 2 or more transmit antennas and then you only have one receive antenna. And then SISO is single input, single output. And then we have a different types of MIMO na in-implement sa cellular network. So we have the 4x4 MIMO, meaning we have 4 transmit, okay, and then 4 receive or the output. Okay, so based sa mga initial calculations, it could quadruple no, yung current throughput mo. Current throughput. So times 4 ang ating throughput. We have 4x2 MIMO if there's a limitation sa ating mga users, mga UE. So there are some user equipments na hindi capable sa 4x4 transmission, so they only have 2 receive antennas, no? So meron lang silang dalawang antennas dito. Kaya siya ay 4x2 MIMO. And then we have the 8x8 MIMO and 2x4 MIMO. Okay? So what are the different benefits of MIMO? Okay, so we have this diversity gain. Okay, so it reduces the impact of fading when the phase on its propagation paths are uncorrelated. Okay, so like for example yung SIMO natin, ano. We also have the array gain. Yan. So yung array gain kanina nakita natin sa droplets of water. So it is achieved from the beamforming effect. Kapag marami tayong antenna elements, so mas nagiging focus yung ating beam. Okay? So kaya siya ay nagkakaroon tayo ng array gain. Tawag natin dyan. So mataas yung gain ng ating link budget. And of course, spatial multiplexing gain. So when our users are separated to each other in space, no? Okay, so it increases the throughput by transferring yung multiple streams of data in parallel using the same set of time and frequency domain. Kasi nga magkahiwalay sila, hindi sila mag-interfere. Okay, so yun yung spatial multiplexing gain. Okay, so when you look at the difference between the single user and the multi-user MIMO, okay, so puntahan lang natin yung single user and multi-user MIMO. So yung single user MIMO allocates yung different subset of BRB to each UE. So like for example, meron tayong isang antenna na meron lang isang beam. No? Yan. Normally, sa isang technology like for example LTE, you have what we call the physical resource blocks. So yung physical resource blocks, ito yung like for example frequency. No? Yan, ito yung mga frequency natin. And then meron tayong time domain dito. Okay? Yan. So parang ganyan yung ating no? Ito yung frequency and then you have the time. So basically, ang ginagawa natin is hinahati natin yung mga subscribers natin. Okay, so for example, subscriber 1, subscriber 2, okay, and then subscriber 1 again, or subscriber 2. So there is a division of the physical resource block. So binibigyan natin ng resource block si UE1 at resource block si UE2. So definitely, for example, meron kang 150 Mbps. If you divide it into 2, so 75 Mbps kay kay UE1, 75 Mbps kay UE2. For the sake of simplicity lang, no, wala pa tayong pinag-usapan na mechanism na na scheduling and then yung RF environment. Pero for the sake of simplicity, if you have 150, you can give 75 and then 75. Now, we have this multi-user MIMO. Natandaan natin, no? Separate yung ating antenna, no? So, if you have this antenna, okay, and then you have a beam, different beams, okay? So, different beams. So, for example, nandito si user A and then si user B. Pwede ko ibigay kay user A yung lahat ng resource. Dahil magkahiwalay naman sila. Separated, no? So, meron siyang meron siyang spatial multiplexing. Okay? So, yung 150 Mbps mapupunta kay A at dito may 150 Mbps ka rin. Dahil yung full na resource ng isang system is na ibibigay mo sa bawat subscriber mo. So, ito yung kagandahan ng multi-user MIMO. But, this kind of technology is using the beamforming mechanism. Kasi ito, hindi ito beamforming, no? Yung single-user MIMO. Itong multi-user MIMO is a beamforming. Okay? So, meron tayong mechanism na pinag-usapan natin kanina. Okay? So, ganitong itsura niya. So, yung beamforming provides a higher spectral efficiency. So, kapag non-beamforming yung transmission, ganito yung ating propagation. No? Wala tayong control. But in terms of the massive MIMO, okay, so one beam can have, for example, 2 layers, or one beam could have 4 layers, no? Yung 2x2 MIMO, 4x4 MIMO. So, ganito yung ginagawa yan. So, paano tayo nagkakaroon ng maraming layers and then maraming beam? So, pag tinignan natin, when you look at yung itsura ng isang massive MIMO antenna, typical, meron tayong 192 antenna sa loob. Elements. Ganyan karami. So, remember, no, sa ating droplets of water, we need more antenna elements to steer the beam. Okay? Para makapag-create tayo ng beams. Okay? So, we have 12 by 8 rows. And then, when you check the design ng beamforming or ng massive MIMO antenna, yung separation ng mga antenna elements niyan is half of the wavelength. Okay? So, if we are using a 3.5 GHz band, so makikita natin ang antenna spacing niya is 4.3 centimeters. Okay? Ang antenna height niyan is 60 centimeters. Okay? 60 centimeters lang. So, less than 1 meter. Ang laki lang yan. So, sir, pwede ba tayo mag-massive MIMO ng 900 MHz or 700 MHz? Pwede, but not practical. Why? Because it will give a very big antenna. Okay? Kasi nga, di ba, yung ating wavelength is half. Yung ating separation is half the wavelength. So, it would look like a big door dun sa ating tower. Ganun kalaki yung magiging antenna natin when we follow this design of massive MIMO. Okay? So, massive MIMO antenna, ganitong itsura niyan sa loob. So, ito yung mga antenna elements separated, half of the wavelength to each other. So, this is an example of a Nokia AirScale massive MIMO adaptive antenna. Okay, so 64 transmit and 64 receive antenna elements. And then when you compare it to different antenna, ito naman yung 88R, yung 8x8 MIMO. So, meron siyang 8 ports, no? 8 transmit. And ganito naman yung massive MIMO natin. Okay, so ganyan yung itsura niyan. Okay? So, pumunta tayo sa application ng beamforming sa ating Open RAN system. So, how do we apply this massive MIMO optimization in the Open RAN? Okay, so massive MIMO is seen as one of the key technologies for 5G with beamforming and spatial multiplexing, as we have discussed earlier. So, this optimization is performed at different time scales from near real-time, transmit time interval, and to non-real-time. How? So, by adapting beam configuration, okay, and policies like PRB usage, and both the non-real-time rig and the near-real-time rig oversee the current traffic, coverage, and interference situation. So, ang ginagawa niyan, so ito yung ating beamforming kanina, no? So, ang ginagawa natin dito is, like for example, meron tayong tatlong beamforming optimization procedure, use cases. Meron tayong non-real-time beamforming optimization. Okay? And then, meron tayong near real-time beam-based mobility robustness optimization. And then, near real-time beam selection optimization. So, I'll just make it simple, no? So, sa non-real-time beamforming optimization, so, ang ginagawa natin dito, for example, the non-real-time rig. Okay? The non-real-time rig can host yung mga X-up. Non-real-time rig can host the X-up to collect, process, and analyze antenna arrays parameter. Yung mga cell performance KPI. UE mobility, nasan yung mga UE natin? CSI, channel state indicator measurement, ano yung status ng RF environment. power headroom reports, yan, and then yung mga neighboring cells, yung mga beams and interference information. So, kinukuha yan in non-real-time rate. Okay? And then, the output can be optimized. Beam configuration. Okay? So, the number of beams, okay? Beam elevation, beam horizontal, vertical beam width, and power allocation of beams. And then, this will be done to achieve yung specific, yung mobile network operator strategy. Such as, for example, yung mga beams natin can cover yung low density areas with wide beams and high density areas with narrow beams. So using this first use case, we can control the beam by using yung mga performance KPIs natin na inanalyze ng non-real-time rig at binaba niya kay near real-time rig para utusan yung mga massive MIMO antennas natin na i-steer yung kanyang beam. Ito yung beamforming optimization. However, dun sa dalawa, no, sa dalawang use case ng near real-time, so sa near real-time rig, may host yung mga apps to monitor the UE traffic density. Where are the UEs? No? Nasaan yung mga telepono? And then UE positioning information. And then beam-based mobility. And then beam failure KPI. So nag-fail ba, no? Ibig sabihin yan, from one, like for example, from this site going to this site, nag-fail ba? Kapag tumatawid siya dito, no? So, in this case, kapag nakikita ng ating non-real-time rig, no, yung ating data, so ibababa niya yan kay real-time rig para magkaroon siya ng configuration about the individual offset ng intercell mobility decision. So, mababago niya yung offset para hindi ito mag-ping-pong effect or mag-fail, no? Mag-beam failure. Okay? Last one is the near real-time beam selection. Okay? So, sa isang site, so marami tayong beam. Okay? Marami tayong beam sa isang massive MIMO. This one is optimizing the intracell beam mobility, such as yung mga massive MIMO beam selection optimization. Okay? So, ginagawa naman ito, it uses minimize yung beam failure rate sa group of users. Para kapag lumilipat ka ng beam, okay? So, alam ng system kung nasaang beam ka, and then kapag may high mobility, so mabilis ka nilang matatransition from one beam to another beam. Okay, so that is the near real-time beam selection optimize function. Okay, so last slide.
Richard, okay.
Yes.
I was about to inform you of the time. Okay, go ahead.
Okay, last slide would be, ito yung latest na isa si Mavenir. Mavenir is one of the vendors pagdating sa Open RAN. So last Mobile World Congress in 2022, so si Mavenir is announced yung kanyang Open Beam radio platform. So ito yung mga Open RAN na massive MIMO antenna niya, no? Anti-active antenna, massive MIMO, and then ito yung mga remote radio unit niya. So si Mavenir release like for example yung 6 GHz na massive MIMO and sub 6 GHz na non-massive MIMO. Kasama din doon sa nag-announce sa Mobile World Congress ng kanilang mga products si NEC at si Fujitsu. Okay? For the enhancement to macro and small cell Open RAN portfolio nila. Okay? So meron ng mga Open RAN na equipment for massive MIMO. Like for example, yung kay Mavenir. Okay? And that's it for today. So, we have very limited time. But I hope bibigyan ko kayo ng mga additional readings for massive MIMO and then mga use cases. And then yung simulation, it's very helpful for you to understand how massive MIMO and beamforming is happening. So I hope you learned something today. So